Hi, this is Mr. West, and today we are subtracting mixed fractions. And this is a hard version from mathdrills.com. Make sure to check out Math Drills in the link in the description below. I also have a playlist for Math Drills. Make sure to check that out. I put a star here with LCM because if you haven't learned the least common multiple yet, you're going to really want to know that if you're subtracting fractions with unlike denominators. I'll link a video that talks about LCM at the end of this video if you want to check it out. But let's go ahead and start with number one. So what's going on with number one is we're subtracting two mixed fractions, and you'll notice that the denominators are different, okay? So the first step we're going to want is we need to find a common denominator. One of the first things you're always going to want to check is to see if the smaller one is a factor of the bigger one, and that's the case here. 3 is a factor of 12. That's part of the process when we're looking at least common multiple, is we're going to see where they line up in terms of, the multiples, the skip counting as some people call it. So 3, 6, 9, 12, okay, that's for the number 3, and then for 12, you'll see that it's 12. This is just a brief intro. 24, 36. And you'll see that they both land on 12. So 12 is the least common multiple, which is why it's going to be the new denominator. So this guy's going to stay the same. We're going to keep this as minus 6 and 11 twelfths. But this one, okay, let me change the highlighter color here. Let's go green. So we're going to change this guy to something else. So let me change this color to green. The 11 we're going to keep. But the 1/3, we want to change that so that it has 12 as the denominator. So this is my process. I know I'm going to have to multiply it by something. Anytime you're creating equivalent fractions, you have to multiply the top and bottom by the same number. We already know that we want it to be a 12. Let me move this over a little bit. So we think to ourselves, okay, 3 times what gives me 12? We multiply it by 4. And you can go up here and see that this was 1, 2, 3, 4. This was the fourth one. Fourth multiple of 3. So we know we multiply by 4, and if we multiply it to the bottom, the denominator, we also have to multiply it to the numerator. So we get 4 over 12. 4 twelfths is the same thing as 1/3. Now we're ready, okay? So we have 11 and 4 twelfths minus 6 and 11 twelfths. This is everything we need to get started. So if you're confused on that step of finding that common denominator, I would encourage you to watch some of my other videos, especially the LCM video. All right, so let's start here. The first thing we can do is we see that we can subtract 11 minus 6. Okay, so if we're looking at the numbers out in front, the whole numbers, we can see, 11 minus 6, we know that's 5. Okay, but here's the problem we run into is we have 4 twelfths minus 11 twelfths. 4 twelfths minus 11 twelfths. And we're going to get a negative number if we do it that way. We're going to get negative 7 over 12. So we don't want to have to deal with negative numbers. At least I don't think it's very helpful, especially for young learners, to deal with negative numbers. So we're going to do something else. We don't want to have to subtract a bigger number from a smaller number. So here's what we're going to do. Since 4 over 12 is smaller than 11 over 12, we're going to change 4 over 12 to be bigger than 11 over 12. How do we do that? Well, we're going to have to borrow. So this is what borrowing looks like. Let me change the color here. Since 4 is smaller than 11, we're going to cross 11 out, and we're going to drop it down to 10. Now, you can't just change a number without doing something else to make it equivalent. So what we're going to do is we're going to add 1 to it, okay? That makes sense, right? 10 plus 1 is the same thing as 11. So that's equal. We can't just make it unequal, just drop it down to 10. We're going to make it equal by adding 1 to 10, all right? Now, I'm going to change 1 even further. Instead of writing 1, I'm going to write 12 over 12. Okay, that's the same thing as 1. So this is still true. 10 plus 12 over 12 is equal to 11. So we haven't changed the problem. We just changed how it looks. And then we still have this 4 twelfths there that we have. Okay, now the 6 and 11 twelfths, he's going to stay exactly the same. Okay, so we're going to keep him the same. There's nothing wrong with him. So now we have a new situation, okay, that we are going to change how this looks because this is a little too complicated. We're going to tidy this up a little bit. So we're going to keep the 10 there, but now we're just going to add this part. We're going to add these two together. And what does that look like? Well, we're going to get 12 plus 4, 16. We keep the denominator the same. And I'm going to go ahead and drop this guy down again. So let's go ahead and move him right there. All right, now this is our new problem. Okay, so the new problem is we have 10 and 16 twelfths minus 6 and 11 twelfths. This is easier, and let me show you why. So we have 10 minus 6. Okay, let me change the color actually, just to show that we're doing something new. So we have, first we're going to have 10 minus 6. Okay, that's one of the problems that we have, and that equals 4. So we know we're going to end up with 4 wholes. Now we are going to take 6 twelfths minus 11 twelfths. So we have 6, sorry, I said 6, I meant 16 twelfths minus 11 twelfths, and that equals 5 twelfths. So we're just going to tag that 5 twelfths on the end, and we're done. Okay, see how that became an easier problem just from changing how it looks and borrowing? Okay, and that's the process we're going to use in this video. Okay, now there's another way you can change all these into improper fractions, but I think this might be a little bit more simple, especially for those that are just starting out. So 4 and 5 twelfths, we just changed how it looks, and there's our answer. Okay, so 4 and 5 twelfths is going to be our answer to number 1. Let me do another one that's a little bit more simple before getting to these 2 tough ones. Okay, so 3 and 8 are a little bit more tough. I'm going to try to go a little bit faster. You can always pause and rewind this video if you're having difficulties, but I'm going to go ahead and move on to another one. And my next one I want to do is, we'll go to this guy, number 9. So I skipped to number 9. Now, you'll notice right away we have different denominators here. So we're going to change that. And I know I need to change this guy, 5, because he is a factor of 40. How do I change 5 to be a factor of 40? Well, I know I need to multiply it by 8 to the top and bottom. So 16 over 40 is my new problem. So my new problem is 8 and 16 40ths minus 3 and 37 40ths. You'll notice right away that 16 is smaller than 37, so we're going to run into problems here real fast. We're going to have to change this problem on the left to look different so that we can do that subtraction. Let's go ahead and do that. So I know I'm going to drop it down to 7. Okay, I need to borrow. I need to make this number bigger. In order to make 16 bigger, I have to borrow from the 8. Okay, that's what that process is. So in order to do that, I take away 1, but I need to keep it equivalent. So I'm going to add on 40 over 40. How do I know 40? Because I'm just choosing the denominator here. Okay, if you're looking to say, oh, what do I need to add by? The denominator, the like denominator. And then I still have the 16 over 40 over here. This guy stays the same. Okay, whatever you're subtracting, that guy's going to stay the same. Now I have 7 in 56 over 40 minus 37 over 40. Don't forget your 3. I'm always forgetting one number here. All right, there we go. Now, this becomes a much easier problem. First thing I'm going to do is I'm going to do 7 minus 3, okay? Just so you see what I'm looking at. 7 minus 3, I'm going to do that first. That's 4. Now I'm doing the 56 over 40 minus 37 over 40. That one's a little more difficult. If you need, you can use the standard algorithm. I just know that it's 9 and then 19. So 19 over 40. If you add 19 to 37, that is 56. Okay. So 19 over 40, and I'm done. There's my answer. Okay. So that it's not too bad of a process with the borrowing. Let's go ahead and jump down to number 3. So number 3 here, this is a tougher one just because 3 is not a factor of 27 or 29. 3 is a factor of 27, but not 29. So you're going to have to find a common denominator by doing a little bit more tricky stuff. Now, some of these are same deal. They're not a factor of each other, but these are pretty easy. We know that 5 and 7, they have a common factor of 35. That's the least common, sorry, not a common factor. They have a least common multiple of 35. One of the strategies you can use with some of these that aren't factors of each other, you can always multiply like 5 times 7, the denominators times each other, to get a like denominator. Now, it may not be in simplest form, but you can always use that method, okay? And again, watch my LCM video on that. But 3 and 29 is not super apparent. So what we're going to actually have to do here is we're going to have to multiply 29 times 3. And that's not a common multiple. So we get 27 here. 3 times 2 is 6, plus 2 is 87. So 87 is our new denominator. And we're going to have to change both of these fractions, okay? So I had to multiply 3 times 29. So I'm going to multiply, this is going to be 29 over 87. I did 1 times 29 to get that. And then I multiplied 29 times 3, so this is going to be 18. That was 6 times 3. This was times 29. And I get 18 over 87. The 3 and the 5 stay the same out in front, okay? And this one's actually not too bad. I don't have to borrow for this one. So this one's going to be straightforward. The hardest part was just doing the denominators. So I have 5 minus 3 is 2, and then I have 29 minus 18, and that is going to be 11 over 87. Talk about an ugly fraction, but that's what it is, okay? So we have 22 and 11 over 87. Let's do one more. So we have 3 and 26 over 35 minus 2 and 1/14. Yuck. Okay, so this one, again, they don't have a common denominator, so we're going to have to find one. Now, you could multiply 35 times 14 to find some long common denominator. I don't want to do that. What I'm going to do instead is I'm going to try just to see. So we have 35 here, just to see if we have a much smaller, easier to find least common multiple. So 35 goes 35, 70, 105. Okay, I think we'll just stop there. 14, let's look at the multiples of 14. We have 14, 28, was that 42, okay, 56, then we have 60. Okay, I don't have anything in common yet. I think I messed up somewhere, if I'm being honest. Okay, so we have 14, then we added 14 again. We have 42, we added 14 again. 56, you add 14 again. It's not 60, my goodness. It's 70. See, even math teachers can make mistakes. So look here, we lucked out, and we got a common multiple here. So we know we're going to change it to 70. So let's go ahead and do that. We're going to write 70 here, 70 here. There's still going to be 3 in front, still a 2, still the minus. Now the top part is the only thing that we need to change. What do we multiply 35 to get to 70? We multiply by 2. This is the second one here, 1, 2. So I'm going to multiply this by 2, and that gives me 52. Now I multiply, let's see, 1, 2, 3, 4, 5. I multiply by 5, so I need to multiply this by 5, and I just get 5. So again, this one's not too bad. So we have 3 minus 2, that's going to be 1, and 52 minus 5, that is going to give us 47, and then that's over 70. So that's our final answer. So really not that bad. Not a lot of borrowing in these tougher examples, but there is borrowing in the first examples. If you need more examples of borrowing, please leave a comment. I like making videos based on requests. That's what this one actually is. And leave a comment if you need any other math concept covered. I really look forward to engaging with my viewers, so make sure to leave a comment. Give it a like, subscribe if you want also, and I look forward to seeing you next time right here on Wes Explains Best.